In section 6.8, graphing absolute value equations, we are going to learn how to translate the graph of absolute value without making a table to graph the absolute value. So let's start with y equals absolute value of x. This is what's called a parent function where all other absolute value equations derive from. So when it's just y equals absolute value of x, your graph looks like this, where the vertex, and vertex is where the V shape meets the point. So vertex is at the origin. So this is your y-axis, x-axis. The absolute value of x with the slope of 1. So when I plug in 1, y is 1. And when I plug in negative 1, absolute value of negative 1 is 1. And same thing is true for negative 2. Absolute value of negative 2 is 2. So my V shape absolute value function looks like this. So absolute value of x gives you a nice V shape with the vertex at 0, 0. So vertex is right here at 0, 0. And when I have y equals absolute value, negative absolute value of x, even though it gives me the same V, it will be a little different from the other one. So when there's a negative on the outside, when I plug in 0 for x, y is also still 0 because absolute value is 0, 0. So the vertex is still at the origin. So here's my vertex at 0, 0. But in this graph, when I plug in 1 in here for x, absolute value is 1. So you put the negative in front of the 1, so it'll be negative 1. There's negative 1. And then when I plug in negative 1, absolute value of negative 1 is 1, and then you put the negative in front of that as well, so it's still negative 1. And same thing is true for 2. 2, absolute value is 2, and you put the negative in front of it, it'll be negative 2. And same thing is for negative 2, absolute value of negative 2 is 2, you put a negative in front of it, it'll be 2, negative 2 also. So when you see a negative on the outside of the absolute value, it will give you an upside down V. So knowing these two information, what we're going to do is we are going to translate or make a translation of this graph by either adding a number on the outside of the absolute value or putting a number in the inside the absolute value of x, and then or both. So let's start with example number 1. So in this equation, I got y equals absolute value of x. And so here's my absolute value of x. So you know it's going to be upright V. And then I'm going to say minus 3. So whenever you have that minus 3 on the outside or plus something on the outside of the absolute value, this is telling me to move this V down 3. So this will be down 3 units. So my graph of this will look like this. So here's the original. Y equals absolute value of x. That was the original. We're going to take this V and move it down 3. So 1, 2, 3. Here's negative 3. So up 1 over 1, up 1 over 1. And then up 1 left, up 1 left. And so then my vertex is at 0, comma, negative 3. So if you see a number on the outside of the absolute value, this will make the whole V transition down 3 units from the origin, with the vertex being at 0, negative 3. So if you see a form of absolute value of x plus k, so k being the number on the outside of the absolute value, and if k is equal to a positive number, the V will move up. And if k is a negative number, the whole V will move down. Okay, so if the number's on the outside of the absolute value, it makes the absolute value, the V-shaped graph, to transition up and down. So then to make it go right and left, what we're going to do is we're going to add or subtract a number on the absolute value on the inside. So if this is absolute value of x minus 2. What this does is we take the original V with the vertex at the origin. Here's the vertex at the origin. And what happens is when y is equal to 0, because it's gonna be along the x-axis, I'm gonna set y equal to 0 and x minus 2, and we're gonna solve for x. And this tells me x is equal to 2. So what happens is that the vertex will move over to the right 2. Here's 2. Here's my x. There's that 2. And the whole V shape moves in that direction. And it makes that V shape so that the V translated over to the right 2. So now the new vertex, right here, the new vertex is at 2, 0. So when you have a number on the inside, this makes the V-shaped transition either to the right or to the left. So same thing, if I did y equals absolute value of x plus 1. So this is on the inside, and if I set this equal to 0, I would subtract 1 to both sides. X would equal -1, so this transition, the absolute value of V, x plus 1, will go to -1, and my vertex would be here at -1, 0, and I go up 1 over 1, up 1, it creates that nice V, so it's transitioned over to the left 1 of that V shape. And that's what the graph will look like. So when it's on the inside, you move it right or left. So this one, move right 2 units. And this one, move left 1 unit. So the general equation for that one will be then y equals x plus h, where if h is negative number, it moves to the right, and if h is equal to a positive number, it moves to the left. Okay? So we're going to put it all together, and we're going to move it both up and down, up or down, or left to right. So in this case, in example number 3, I have an equation of an absolute value that looks like this. Y equals absolute value of x minus 2, and then I have plus 3 on the outside. So the outside number says it's got to move up 3 units, and then the inside, because it's negative, it says move right 2 units. So the vertex would be at 2, 3. So my graph would look like this. So right 2, 1, 2, and then up 1, 2, 3, up 1, 2, 3. So there's the vertex, and because this is a positive absolute value, I gotta go up 1 over 1, up 1 over, and then right this way, and it's an upright V that looks like this, and that will be the translation of this graph. So the general equation for absolute value would be y equals absolute value of x plus h plus k, where the k, if it's positive, moves up, negative moves it down, And then on the inside, right here, if it's negative, if it's positive, it moves left. If it's negative, it moves right. Where the vertex is at negative h, opposite of h, and then comma k would be your vertex.